Hello, my name is Adrian and I am a student of Polytechnic Solution University. Now I'm going to talk about the physiological control system. And for the abstract, during the past several years, physical control has emerged as one of the most active and fruitful areas for research in the applications of physics theory, especially in the railway industry process, which do not lend themselves to control by conventional methods because of a lack of quantitative data regarding in the input-output relations. The Fuzzy Logic Controller, if LC, the cell and Fuzzy Logic provides a means of converting a linguistic control strategy based on expert knowledge into an automatic control strategy. The project about control system includes a discussion of fusification and defusification strategies, and fusion control rules, the definition of fusion implication, and an analysis of fusion reasoning mechanisms. For the physics sets and physics logic of the card, we have the first topic that is physics set and terminology. Let U be a collection of objects denoted generally by U, which could be discrete or continuous. U is called the universe of this curve, and U represents the generic element of U. A physics set F in a universe of discourse U is characterized by membership function, which take the value in intervals 0 to 1. And for the car, we have set cruise inputs. That is the second topic. Set two physics sets, left sensor and right sensor, are the cruise inputs of the physics implication inference. It's based on the compositional rule of inference about the distance to an stack. The specification interface involves the following functions: measures to the value of input variables, perform a scale mapping that transfers the range of value of input variables into corresponding universe of this course, perform the functions of specifications that convert input data into suitable linguistic values, which may be viewed as label or fuse set. The specification interface performs the following functions: scale mapping, which convert the range of value of output variables into corresponding universe of discourse; the specification with yields a non-fusing control action from the inferred fusing control action. Now, I'm going to describe the main ideas underlying in the FCL in terms of fuzzy logic. The structural parameter involved in the design of an if-else file, fuzzy conditional statements, and fuzzy control rules. In an FLC, the dynamic behavior of the fuzzy system is characterized by a set of linguistic description rules based on expert knowledge. Um, in our terminology, a fuzzy control rule is a fuzzy conditional statement in which the antecedent is a condition in its application domains, and the consequence is a control action for the system under control. Design parameters of if-else. The principal design parameters for an if-else are the following: specification strategies and interpretation of a specification, rule base, choice of process state input variables and control output variables of physics control rules, source and derivation of physics control rules, type of physics control rules, consistency, interactivity, completeness, and physics control rules, decision making logic, definition of a physics implication, interpretation of the sentence connective, and definition of a compositional operator, inference mechanism, and the specification strategies, and the interpretation of the specification. Basic logic with carry implements. This is the left sensor and right sensor, and we receive two previous input, and in the Arduino process this input and then send the physics logic for the degrees to rotate the servo motor. Well, now I am going to talk about the code explanation. We use a NetBeans X.0. This project consists of a class that in the main window and two libraries, one for Arduino and one for the physics logic. This library, Panamatic Tech Arduino, is for the receive and sending data, and for the physics logic is for the physics logic in Java. In this part of code, we have a connection Arduino with Java through COM3 and port serial listener. I use the library Panamatic Tech Arduino for receive data with the interface serial port event listener that implements the method override serial event. In this method, I receive the data from the sensors for the fuzzy and inference the argris put input. And this method infer has a left and right parameters that are the data for the diffusion using the photophysics logic library. Also allows me to send data that are the degrees to rotate in servo motor. This is the file controller diffuser. Allow me set the crust input for the specification and the specification. The system is characterized by the self-linguistic description rules based on expert knowledge about approximation statements. This file is the sonar servomotor has servomotor and position variables from the data received from Java. For the left rotation weights 100 mm and for the servo, and right rotation weights 18 for the servo. And the conclusions are the importance of a physics logic has two principal approach to the evaluation of a physics control rules. The first is an heuristic method in which a collection of physics control rules is formed by analyzing the behavior of a control process. The control rules are derived in such a way that the deviation from a desired state can be correct and the control object can be achieved. Another approach, based on physics relational equations, is directed at the same problems. The structure identification requires the determination of the system order and time delays of discrete time physics models, while the parameter estimation reduces to determination of the overall physics. relations matrix from the input-output data of the system. And this is the reference that I use for this project.